Good afternoon, everybody. My name is Merville Palmores, and today I'll be presenting my work-based project called Adaptix, an intelligent framework for cost-efficient adaptive log analysis. This project introduces and validates an innovative framework for log analysis that addresses a critical challenge in modern AIOps, which is the trade-off between high cost of advanced AI and the need for deep operational insights. The core of this project addresses a significant strategic problem, which is the high cost and the operational latency and log analysis using large language models. Based on evaluation of a number of literature, the industry faces a false dichotomy. Traditional parsers, they say, are fast and cheap, but they are inflexible. Or LLMs, they're powerful, but they're expensive. As Gardner reports, there is a high financial risk in observability alone. In the report, companies faces up to about $800,000 budget annually just for observability within their operational cost. And as you can imagine, adding LLMs on top of that makes them shy away against advanced AI solution. So my project central hypothesis is this, that a hybrid architecture combining a range of advanced and emerging skills could resolve this conflict and deliver a solution that is both powerful and economically viable. So the solution is Adaptix, an innovative framework built on the principle of lazy LLM invocation. The methodology introduced in this project is of significant industrial relevance. After consulting with our internal patent team and legal team, they deemed that my solution is currently patentable. And currently, it is a subject of a non-provisional patent application. The architecture of this framework is the primary intellectual insight of this project. It consists of 4 layers. So first is the high-performance adaptive cache. Second, the intelligent cache mishandling step to filter out the noise from the actual anomalies or actual logs that we need to get insight from. A surgical LLM invocation, which is only designed for true anomalies. And finally, and the key innovation, which I called here is KG-RAG, or the Knowledge Graph Retrieval-Augmented Generation. This module, based on sustained research into the limitation of standard RAG systems, allows the LLM to perform causal reasoning and not just parsing. And this architecture is a direct result of evaluating and comparing complex data and literature on existing methods and designing a superior alternative. The methodology is systematic, and it has 2 parts of it. The first part is the offline, and the second one is the online. In the offline phase, I justify the use of Drain 3 and TF-IDF with KNN because of their speed and efficiency. If you want to learn more about how I've chosen TF-IDF and KNN, is actually detailed in my paper. The online pipeline shown here is the core of the cost-saving mechanism. As you can see, the fast path handles the vast majority of the logs. And when it misses that fast path, I call it the cache miss within my solution, is the actually which introduced the intelligent path. And this intelligent path does not immediately call LLM. Instead, a similarity check filters out simple variations. And this ensures that expensive LLM calls are only used when absolutely necessary. Each of these techniques was deliberately chosen as the most appropriate for his task. Now, my solution detects anomalies. And for true anomalies, the Adaptix uses a unique hierarchical demonstration selection method. The purpose is to select the best examples that we can send for LLM as a prompt, and it uses a filter then rank similarity method. The cache then evolves using the robust longest common sequence metric, subsequence metric. And the most innovative component, again, is the KG-RAG module. As shown in the diagram on the right, the hybrid KG-RAG module traverses a graph of systems architecture to retrieve structural relationships, giving the LLM the context it needs to perform genuine causal reasoning. And for this, overcomes the limitation of a standard RAG systems. To validate the framework, I deployed it in a real-world setting. And the results were compelling. The system processed over 500,000 logs in a span of 5 days and achieved a stable cache hit rate of over 92%. As you can see in the graph, as the cache learned, the number of expensive LLM calls dropped dramatically. This demonstrates the framework's efficiency and scalability. During the project, I also had to adapt. I critically evaluated my own process and pivoted from parallel processing to sequential processing. In my process, I proved that parallel processing did not work. So sequential processing so far was robust and effective. In this slide, I just want to show you the results of one of the final and most critical experiment I've done, which is the end-to-end cost performance. I captured, analyzed, and compared performance data between Adaptix and the naive baseline. And the interpretation is actually clear. Adaptix reduced LLM calls and latency by over 95%. But the most insightful conclusion comes from the accuracy. The naive baseline completely failed. This allows me to state with confidence that the intelligent architecture of Adaptix is not just a nice to have proficiency, but it is a fundamental requirement for success. My project, I also evaluated critically in terms of the anomaly detection and found out some limitations. The confusion matrix shows that the anomaly detector is a high recall and a low precision filter. At the time of the project, this was a deliberate strategic choice. I designed the system to be highly sensitive so that no potential anomaly is missed. The subsequent KG-RAG module anyway provides the deep context needed to distinguish true issues from benign variations. The primary limitations are the dependencies on initial templates and the semi-automated nature of the knowledge graph construction, which I believe are the key areas for future work. In terms of the governance, risk, and professional practice part of this project was executed with a strong focus on professional practice. And I adhered to all the employer's data governance processes and GDPR because I know the consequences of failing to do so are severe. And the architecture itself, the solution, is actually a form of a data protection by design. Furthermore, I work independently to meet the project deadlines, as outlined in the project Gantt chart. Prioritize tasks to ensure that the core business objectives of validating a cost-efficient model was met first before moving into a more advanced research aspects. In conclusion, Adaptix provides a validated blueprint for the next generation of AIOps tools. The future work identified will have a direct positive impact on business, reducing workload for colleagues and improving their operational efficiency. The ultimate vision, as shown here, is to actually evolve the Adaptix into an agentic framework for autonomous remediation. From a financial perspective, this would be a significant step, moving from cost savings on analysis, cost savings on operations, by reducing system downtime and the need for manual intervention. That's all I have for you today. Thank you so much for listening. I hope you enjoyed the presentation. Bye-bye.